If you were to be presented with the words ducks and cardinals all by themselves, would you think, are these birds or sports team names? You might say you would need more context. Well, so would AI. Fortunately, embeddings can help us figure this out. How do embeddings help us provide context? Well, the words are converted to a special kind of number called a vector embedding. We sometimes refer to this simply as an embedding. Embeddings place words with similar meanings and contexts close to each other. A model, which would be trained on something like sports data, would then place ducks and cardinals near things like football, baseball, etc., while a model that was trained on natural history would place ducks and cardinals near quack, water, and other similar words. But why do we have to use numbers? Why can't we just compare words? Well, first is the idea of ambiguity. The word duck could refer to a bird or a sports team. Without understanding the context, a search might incorrectly return results. Another is the idea of vocabulary mismatch. Hunger, hungry would mean different things potentially to a duck as opposed to a sports team. Lexical or word-by-word text searches is either a match or a no match. Duck doesn't match the word bird or sports team, and so you're losing out on similarity there. Well, how does this all work? If you ask a chatbot, for example, whether the Oregon Ducks or the St. Louis Cardinals have a better winning percentage in their respective sport, the chatbot would use its model to take a look at the question and turn that into an embedding, then use its internal knowledge along with that embedding to determine you're interested in sports teams, not birds. It would then find the closest similarities between the embeddings of the question and the source text, and then it would use all that information together to formulate an answer and give it to you. For example, here's a hypothetical embedding, the first 20 of 768 dimensions, for the text that we covered in the previous slide. These numbers have captured concepts such as comparison, the specific entities of the teams, the subject of sports domain, and this is a question. The vector could then be used in a similarity search to find other documents or questions that are semantically close, even if phrased differently. Bringing this all together, here's an example of a chatbot where I have asked the question whether the Oregon Ducks or St. Louis Cardinals have a better winning percentage. So first, the model clarifies the user's intent, knowing that it's interested in a football and baseball team. So now it looks up the all-time winning percentages for those teams, assuming it has access to this information. It examines the winning history, calculates the percentages, and then finalizes the comparison. Based on all of this, it returns an answer. In this case, it determines that the Oregon Ducks football team holds a slight edge over the St. Louis Cardinals. In closing, remember that no two models are the same. The embedding model and the dimensions, or the amount of embeddings, that are produced for the source text must be the same embedding model and dimensions that your AI apps and agents use as well. Why? Well, again, remember, embeddings capture a text's semantic meaning with a fixed number of dimensions. If you mix models or dimensions on either side, this will break the system, because it's trying to compare or match vectors of different formats and sizes. It's kind of like trying to fit a square peg in a round hole. Well, for now that's it. Hopefully you've understood more about what embeddings are, why they matter, and how they can help you.